it says a block of mass 34 kilograms, M1, is on a horizontal surface and it's connected to a mass M2, 16.5 kilograms, hanging vertically as shown. The two blocks are connected by a string of negligible mass passing over a frictionless pulley. And there's a coefficient of kinetic friction given to be 0.25 between M1 and the surface that it's resting on. Using the same technique that I had used in previous problems, I'm going to unwrap the problem and make it into an analogous, just linear setup. M1 is there, M2 is here, and I'm going to consider the whole thing to be the system at the start. Alright, so what forces are relevant? Well, M2 hangs in a gravitational field, so it's going to feel a gravitational force. Call that Fg2. M1 has a weight as well. It would be canceled by the normal force. And there's also going to be a tension force. So we can call that Ft. But what's different about this setup that is new is there's going to be a kinetic friction force as well. Now, I don't know how large the friction will be, but if our M2 is to fall down, then we need for the friction force, Fk, to be less than the tension force. Alright, so we're asked for the magnitude of acceleration of the hanging mass, so we want to get the net force on the system. To do that, I'll analyze my linear analogy here. There is a weight that pulls against the string, like in the opposite direction of the cable there. That's Fg2. There's another external force, like a force that is felt due to some outside influence, is what I mean. And that would be this frictional force right here. Yeah, so that force is going to be Fk for kinetic friction. There's tension in the cables as well. There's tension inside the system, but that is not going to contribute to the net force because the force of tension pulling to the right will balance with the force of tension pulling to the left. So it's not needed to find the acceleration, is what I mean. But let's find the net force. It's going to be relative to the x dimension here, so I'm going to make to the right positive x. And that means that we would have Fkx plus Fg2x being the only two forces that matter. So how do we find Fk? We're going to need to use mu k, which is the coefficient of kinetic friction. And we'll also use the normal force of block 1 for that. That's just part of the kinetic friction formula, which says that Fk equals mu k times Fn. And we want to make it negative, though, so that it's to the left. Now, when it comes to Fg2x, we'll just use m2g, and we want that to be positive because it is pulling to the right. Alright, so I can further plug in, like Fn is going to be found by m1 times g. Okay, that just comes from the weight idea, that the normal force is equal to the weight of block 1, and that's equal to m1g. So we'll get that, and then we'll have this. So let's just plug in everything that we can. 0.25 is the coefficient of friction that they gave. 34 kilograms for M1. G is 9.8. M2 is 16.5 kilograms. Alright, let's calculate it. I'm getting 78.4 newtons for our net force. And it is positive, I notice, so that means that our M2 will fall down, which is normal. Alright, so now let's get the acceleration. That'll be found by dividing our net force by the total mass, though. So we're going to have 78.4 newtons. And let's see, 34 plus 16.5. I get 1.55 meters per second squared. That'll be our acceleration. Next, we're asked for the tension in the cable. We'll want to analyze a different part of the setup and make a new system. So it's our choice which block we want to focus on now. The hanging one has less forces on it, so it's a little bit easier to analyze. Alright, so what are the forces on this? Yeah, we've got FG2 and FT. So it should be that the net force on 2 equals M2 times A2, and then we can plug in that our net force is found by FG2 minus FT, and then plug that in. Alright, so FG2 is going to be M2 times G minus FT equals M2A, 16.5, 9.8 minus FT, 16.5, and then we'll use our acceleration that we found previously. Yeah, this should allow us to find FT. I think I'm getting 136 newtons.